different types of intersections, and we're going to start here with intersection of a line and a plane. Okay, so here are the three cases. You can have one point of intersection, so the line goes through the plane. Okay, so it crosses at only one point. It can only cross at one point, right, if it's going through the plane. It can have no solution, so that means that the line is parallel to the plane, or it can have an infinite number of solutions, and that's when the line and the plane are coincident, so it just means that the line lies on the plane. Okay, so these are the three cases. So here we have a line and a plane. So find the intersection of the line and the plane. And we're not sure which situation we have, so we're going to try to come up with a solution and see if we can come up with a solution. All right, so what do you think we should do? What do you guys think? I need to find a point of intersection if there is one. Any suggestions? Come on.
Do you plug in the points?
Like plug in what points?
The parametric equation.
Oh, okay. So if I find the parametric equations, then that's giving me an expression, yes, for X, Y, and Z. Very good. It's giving me an expression from the line of X, Y, and Z. So I can sub that into the plane. And what's that going to do? So I'm going to come up with an expression for X, Y, and Z. And I'm going to plug that into the plane. And then am I going to come up with a point? Where do we go from there? What am I going to end up with?
A t value.
Excellent. You're going to get a t value. Okay. I don't know why I can't, having issues here. Hold on. Good. You're going to get a t value. And then once you have a t value, what are we going to do from there? You know what, guys? It's not allowing me. Let's see if I can do it this way. Go down. Okay, hold on. I'm going to try closing this file and opening it up again. Give me a sec. Okay, my connection was lost, but I'm back. It was very quick. So let's find my file. Let's try that again. Everyone can hear me?
Yep.
Good. There we go. Okay. So let's find parametrics of the line. So finding parametrics.
Yes, you are presenting.
Oh, I'm not. I apologize. Okay, so finding parametrics of the line. What do I have? Who can tell me what I have? X equals, Y equals,
1
Z
plus 2t, 6 plus 3t, negative 5 plus 2t.
Sure. Good. So now, here are my parametrics. We're going to take these and we're going to sub into our plane. And I'm going to solve for t. So I have for my plane 4 times x minus 2 times y. And then plus z. And then minus 19. And I'm going to solve for t. 4 plus 8t minus 12 minus 6t. And what do I get here? What does t equal? t equals 8. And now I need to find a point. And I know that my t value is 8. And so I can go back to my parametrics and sub this in, and it will give me the point that intersects the plane. Because this is the value of t, right, that satisfies our Cartesian equation, which is our plane. And so now I had x equals 1 plus 2t. Negative 5 plus 2t. And so subbing in, I get 17. I get 30. And I get 11, 16 minus 5. Therefore, the line intersects the plane at the point 17, 30, 11. Are there any questions? Okay, let's do another example. So here I'm given symmetric equations and I'm given a plane. So again, we're going to go to parametrics. You guys are still with me, right?
Yep.
Yeah.
Thank you. All right, so from here, I have x plus 4 divided by 3 equals t. So what does x equal?
Negative
So
4 plus 3t.
Sure. Okay, what about y?
0.
Yep. And z is just t. Okay, so now you take this and you sub it into pi. Right, into your plane. Three t plus 4 equals 0. Okay, and from here, what do we get? Looks like I'm going to get 3t minus 3t and negative 4 plus 4. So what's happening here? 0 times t equals 0 or 0 equals 0? What happened?
It's on the same plane.
Good. How do you know? How do you know it's on the same plane?
Because you can sub in any value of t and it works.
Exactly. This is a true statement. 0 always equals 0. So that means that any value of t will suffice. And so therefore we know that it's an infinite number of solutions. Okay, so this is a true statement. So I have 0 times t. Well, no matter what t is, when I multiply it by 0, it's going to equal 0. Okay, so therefore I know there's an infinite number of solutions. And the only way that there can be an infinite number of solutions is if the line lies on the plane. Okay. So what about if you got a false statement? What do you think that would mean? So what about if you got something like this? Or what would a false statement look like?
0t plus 4 equals 0.
0t plus 4. Okay, sure. So it'd be something like this. Right? Brian saying 0t, Did you say plus or minus 4? Not that it really matters. I think you said plus 4.
Plus.
So that's showing us that 0t equals -4. Well, there's no value of t I can ever sub in there to make this equal -4. This is a false statement. So what do you think this means? No value of t that I can ever sub in to make that Cartesian equation work. So what does that mean?
Doesn't intersect.
Exactly. They don't intersect. Okay. Okay. Perfect. Okay. This is a false statement. Never true. Good. Okay. So here I have intersection of two lines in 3 space. So now I have 2 lines. So how can these 2 lines intersect? Well, they can intersect at one point. They can intersect infinitely many times, which means that they are coincident. So one line is right on top of the other. There could be no solution, meaning that the lines are parallel, or there could be no solution, but the lines are not parallel, they're skewed. So they never meet, but their direction is not the same. Okay, they're not parallel. Okay, so we have that extra, that's something that's new for you guys, right? The first 3 cases is the same as in 2 space, but the 4th case is new. Okay, skew lines. All right, so example 3, find the intersection of 2 lines, given both of these lines in symmetric form. What should we do? What do you guys think?
Put them in parametrics.
Okay, put them in parametrics, because then we have an x, a y, and a z, right? So remember, guys, we're always trying to find a point of intersection. So we're trying to find an x, a y, and a z that's the same. Okay, so good. So we're going to put them into parametrics. So I get x equals 3t minus 1, 4t plus 1, and z equals -2t. That's my line 1. And we're going to do the same for line 2. And so I have 2s plus 5. Make sure you change that variable. Oops, it's not line 2, it's x. And then we have y is equal to 3s plus 9, and z is equal to s minus 4. Okay? What are we going to do next? Well, I have x equals 3t minus 1, but I also have x equals 2s plus 5. And we're trying to find where s is the same. So I'm going to set them equal to one another.
We missed. Why do you not check the slope first?
I'm sorry, say that again.
Why do you not check the direction vector first?
Because even if the direction vector is the same, I'd still have to find out if they're coincident or parallel, correct?
Oh, okay. Yeah.
Okay, so 3t minus 1 equals 2s plus 5. 4t plus 1 equals 3s plus 9. And my third equation is -2t equals s minus 4. And this is just regular substitution, guys. So, of course, it can be done many different ways. But by looking at these 3 equations, what do you think is the easiest one that I should solve? This one, because it's already isolated, right? So I can see that s is equal to What am I going to do next then?
Sub that into the other equations.
Yeah, I'm just doing substitution, right? I'm just going to call it 3. And I'm going to sub it into 1. And so from 1, I have 3t minus 1 equals 2 times s. And now we can solve for t. So we go ahead and solve for t. 8 minus 4t plus 5. 3t plus 4t is 7t. 13 plus 1 is 14. And so I have t is equal to 2. And now, this is so now we're going to sub t equals 2 into number 3 because I'm already solved for s. And s is equal to 4 minus 2 times 2. And s equals 0. Okay, so now I found an s and a t. I need to find x, y, and z. What should I do?
Sub them back into the parametrics.
Yep, sub them back into your parametrics. So for line 1, I'm subbing in my t. And for my y. So go ahead and sub those in and tell me what you get. Okay, so what do we get for the first one? Subbing in t equals 2. Negative 1. And for the next one? 1 plus 8, right? And for the next one?
-4.
There you go. So we're getting the 0.5, 9, negative 4. So can I stop here because I got a point? What do you think? Should I just stop here and say, oh, we got the point of intersection?
We should check if it's the same for the other one.
You got it. Check, because they're not always going to be the same, right? You want to make sure that the 2 points are the same. So then you know that you, in fact, found a solution. Okay? So now we're going to do the same thing with s. We're going to sub s into line 2. So x equals 5, you can very clearly see, right? Because it's 0. And because we got the exact same coordinates, we know that they do intersect at that point. Cool?
Miss.
Yeah.
If you find the values and after we check, like they give us two sets of different values, that means like these lines that are parallel or like they don't intersect. Like if
Yeah.
we
Yeah.
okay, like that's the answer. If they don't if it gives us like two different sets of coordinates, then they're parallel.
You have to distinguish. Are they parallel? Are they skewed? Right? So you have to, and at that point, we're going to do what Brian said. We're going to analyze the direction vectors because the direction vectors are going to help us realize whether they're parallel or they're skewed.
Oh, yes. Yeah, true.
Right? Okay. So that's the added step there that we need to. So let's take a look at this example. So we're going to do this the exact same way. We've got 2 lines. We're going to bring it to parametrics. We're going to use substitution. Okay, so we're going to try to solve for an s and a t. So What are the parametrics for line 1? Who can tell me? Oh, come on, everyone should be able to tell me.
2 plus t for x,
Mm-hmm,
1 minus t for y,
mm-hmm,
and then t for z.
perfect. Line 2,
We have 3 plus 2s,
yep,
and then 3s,
okay,
and then negative 1 minus s.
good. So here I have 1, 2, 3, setting them equal to each other. So my first equation, I want my x's the same. My second equations, I want my y's the same. And then my third equation, I want my z's the same. Okay. So now what? What should I do from here? Which one should I work with?
Sub 3 into 2.
Yeah, 3 is already isolated for us. All right, so I sub 3 into 2. And so I have 1 minus. Okay, and so what do I get here?
S equals 1.
Good. And now we're going to sub this into 3 because it's already solved. And we see that t is equal to -2. So I have an s and I have a t, and so now we just sub back into the parametrics of both lines. So we have 2 plus t, 1 minus t, and t. Subbing in -2. We've got the point 0, 3, -2. So now let's check it with line 2. So 3 plus 2s, 3s, -1 minus s. 3s. Okay, so subbing in our s value, which was 1, what do I get? 5, 3, and -2. So what can I conclude? Take a look.
They don't intersect.
Yeah, they don't intersect. And it's not enough for me to just say that they don't intersect. I want to know why they don't intersect. So when I go to look at my possibilities, if they're not intersecting, then the two solutions are either they're parallel lines or they're skew. It's one of the two. So now, how am I going to figure it out? Well, I'm going to take a look at their direction vectors. So take a look at their direction vectors. What do you guys think?
Not parallel.
I'm sorry, nice and loud?
Not parallel.
They aren't, right? One is not a scalar multiple of the other. And since one is not a scalar multiple of the other, we can say that the two lines are skew. Okay? So skew again, guys, means they're not parallel, but they're not crossing. Okay, so they're running in different directions in 3D space, but they don't cross. Okay. Are there any questions?
So Miss, if they were coincident and you sub the parametrics into each other, would you get like the T's and S's cancel out?
You're going to get a true statement. Yes.
Okay.
Yeah. Okay. All right. All right. So this is your homework. Numbers 1 to 17. On page 496. Okay, so we're going to do 9.2. 9.2 is not so long. Yeah, question?
Yes, I have a quick question. So for
Sure.
this kind of questions, they always give it to us in a like in the vector form. Like, is it possible they give us the Cartesian equation of the two lines, and then if
Yeah, we're going to talk about that as we move forward. So for today, we're just going to look at them in terms of a vector equation, parametric equation, or symmetric equation. So
Oh,
Cartesian
okay.
equation we'll talk about later on, okay?
Okay, thank you.
Yeah, no problem. Okay, so, and let me ask you this, Asan. So if you're given the Cartesian equation, right? So then what do you think we're going to have to concern ourselves with? So let's say that we have two planes and we want to know how two planes intersect. What do you think we're going to need to concern ourselves with?
If we only have the two planes,
Yeah,
I mean,
two
if you
planes,
have to,
both Cartesian equations.
oh, okay. So like, what we can do is like see the normals
That's right.
and see, yeah, okay. And then
We're
like
going
if
to
the
have to work
normals,
with the normals.
oh, and then it's
Yeah.
like what I thought was like, so like if the normals like they don't give us any information. Like if the two normals were like different, what we can we just like then find the like x or y or z intercept of both and then do it?
Well,
Or-
we're going to analyze, we're going to analyze the normals and then we're going to go from there to figure out what we need to do to solve, right? But we'll get there. That's later on. That's tomorrow's lesson.
Mhm.
Okay? Yeah.
Okay.
Yeah. Okay. So do you guys want to start 9.2 right away? Or do you guys want to take a break? It's up to you.